Hi everyone, today we are talking about how to solve one-step equations. So by now you should know that an equation is called an equation because the left side and the right side are equal to each other. That's where the root equate or equal in equation comes from, because we have a math sentence that shows one side is equal to the other. So using the analogy of the scale, in order to keep both those sides equal to each other, but also solve for what the variable is representing, what value it represents, we need to perform inverse operations or opposite operations on both sides. So to review, adding and subtracting are inverse operations of each other. They undo each other. And multiplication and division are inverse or opposite operations. Make sure you have that in your notebook. We're going to go over this first example without using a scale, but using the same concept of a scale. We're going to solve it algebraically. So we're just going to do our math as opposed to drawing our pictures. But as a reminder, this equal sign is like the balancer in your scale. So it shows that x minus 5 in this equation is equal to the value of 11 on the right-hand side. So I'm going to go ahead and draw a line down from the equal sign to show that these are my two different sides. Now, when it says to solve the equation x minus 5 equals 11, what they really want to know is what x is equal to at the end. They want to know what the value is for x that it stands for. We have a subtract 5 on this side that's attached to the x. Remember, we want to get x by itself on one side and have a value on the other so that we know that they're equal to each other. So this minus 5 I need to get rid of so I can get x by itself. It's subtracting 5, so the opposite to get rid of it would be to add 5, because addition and subtraction are opposites of each other. So again, we decided to add 5 so that the minus 5 and add 5 would cancel each other out because they're opposites of each other. However, if I'm adding 5 to one side of the scale and not to the other, it's going to be lopsided, so I need to, in order to keep it balanced, also add 5 to the right-hand side. So again, I just have x left over on this side, which is what we wanted, because the 5s cancel each other out because they're opposite signs. And then on the right-hand side now, I just have 11 plus 5, which is 16. So then that answer would be x equals 16. If I wanted to check my work, all I need to do would be to substitute that back in. Instead of x minus 5 equals 11, I have 16 minus 5 equals 11. 16 minus 5 is 11. So at the end, I get a true statement. So I know that my answer x equals 16 is correct. Let's try another example using our inverse operations to keep our equations balanced. This one says to solve the equation x plus 6 equals 13. Go ahead and pause the video and try it on your own first. All right, so I'm going to draw a line down where I see my equal sign to show that that's the left-hand side and that's the right-hand side. At the end, I want an answer for x. So that means I need to get rid of this plus 6. In order to get rid of it, I need to subtract that 6. And to keep it balanced, I need to also subtract 6 on the right-hand side. So then I just get x left over, which is what I want on the left-hand side. And the right-hand side is 13 minus 6, which is 7. I'm going to check my answer to make sure it's correct. So instead of x plus 6, I have 7 plus 6. And that should equal to the right-hand side, which is 13. 7 plus 6 is 13, so I get a true statement. So that means my answer is correct. X is equal to 7. Let's try example 3. Pause the video and try this one on your own first. Okay, so again, drawing a line down where my equal sign is to separate my left and my right-hand side. This right here, x over 4 equals 7, really means x divided by 4. Okay, so x over 4, remember, is the same as x divided by 4. Now, the reason they are writing it this way is just because, fractions also mean division, because fractions are dividing a piece into equal sizes. But it's really the same thing. So I'm dealing with a division of 4. Well, the opposite of division is multiplication. So instead of dividing by 4, the opposite or the inverse operation would be to multiply by 4. Okay? Because again, I want to do the inverse operation so I get x by itself to get the answer. Okay, so I'm actually going to rewrite this. X over 4 equals 7 because I want some space over here. So my inverse operation is to multiply by 4. So I like to write it on the side like this. Multiply by 4 over 1 to show that I have a 4 on top and a 4 on the bottom. So that's how they cancel each other out. Okay, and then I also need to show that I multiply by 4 on the right-hand side to keep my equation balanced. So again, I was able to cancel out my divide by 4 with a multiply by 4 over 1 so that the top has a 4 and the bottom has a 4. Please try to get into that habit, because I've noticed sometimes when people don't write it like that, they just go like this, multiply by 4. Sometimes they will end up getting x over 8 because they don't see that this 4 is actually over 1. That's not correct. They don't see that it's over 1, and they actually cancel each other out. They end up keeping it on the denominator, and you didn't actually get rid of the divide by 4, right? So just keep that in mind, that multiplying by 4 doesn't mean you're multiplying by 4 on the bottom. It's 4 over 1. Multiplying by 4 on the bottom would be multiplying by 1/4, right? 1/4 times x over 4 would equal to x over 8. So just be aware of that. All right, so we canceled it out because we have 4 on top and 4 on the bottom. So x is left by itself on the left-hand side. We want that. And then on the right-hand side, we have 7 times 4, which is 28. I want to check this answer because, especially if I know people normally get this type of problem wrong. So instead of x divided by 4, I have 28 divided by 4 equals 7. 28 divided by 4 is 7. 7 equals 7. That is a true statement. So then I know that x is indeed equal to 28. Let's work on example 4. Pause the video and try it on your own first. Okay, so I'm going to start off by drawing a line down where I see the equal sign to separate my left side from my right side, because I want to make sure I'm performing inverse operations equally on both sides. And I know I need to solve for x equals whatever the value is. This is -6 multiplied by x. So if you need to rewrite it like this with your parentheses to show its multiplication, or with a dot, as long as it doesn't confuse you, please do that. But most of the time people will look at this and they'll see the negative in front of the 6 and they'll think it's subtracting 6. But keep in mind, this is not a subtraction problem, it's a multiplication problem. You're just multiplying by a negative value. If it were a subtraction problem, it would look like this. X minus 6 equals 8. But this is not that problem. This is a multiplication problem. This is x being multiplied by -6. So the opposite would be to divide by -6. And I want to make sure I'm dividing by the 6 and the negative, because both those will cancel out. The 6 on top and the 6 on the bottom will cancel. The negative on top and the negative on the bottom will also cancel. A big mistake that I've seen people make is they'll just divide by the number, the 6, and then they cancel it out, but it's actually not canceled. At the end, they're not left with just an x. They're left with a -x. And we don't want to look for a negative value of the variable. We want to look for just the variable by itself. So you want to make sure you're dividing by the value and the sign so that they both cancel out and you end up with the positive value of the variable left over. So this is dividing both sides by a -6. So then both of those cancel out, top and bottom. You end up with an x on the left-hand side, and your answer is -8 over 6. Okay? negative 8 over 6. I'm going to erase that so I have room. Negative 8 over 6. You could keep it like that or change it to a mixed number. So 6 goes into 8 one time with the 2 remaining. So you have 1 and 2, 6. Negative. Negative 1 and 2, 6. I can reduce that by dividing top and bottom by 2. So I end up with negative 1 and 1/3. Okay, so that's my answer. I can go back and check my answer, especially since I have a fraction. So instead of negative 6 times x, I'm going to do negative 6 times negative 8 over 6, and that should equal to 8. Let's see if it works. Well, when I plug it back in, the 6, there's a 6 on top and a 6 on the bottom, they cancel, and I have negative times a negative 8. Negative times negative is positive, so I end up with a positive 8 on the left-hand side and a positive 8 on the right-hand side. So that checks out. My answer is correct, because at the end, the 6's canceled and the negatives canceled each other out, so I ended up with a negative 8/6 as my answer, or negative 1 1/3.